All right, welcome to another episode of the Scripting Them podcast, the place where I use my 20 years of experience to shed some light into the IT industry, your career, or anything dev related. So, in this episode, I want to cover the topic of picking your tech stack, essentially, whether it's for your whole startup or your next side project, whatever it is. I just want to give you a couple pointers and share some tools that you can use. So, let's go. All right, so the first, let's just get that definition out of the way. What is a tech stack? A tech stack is essentially the ecosystem of technology that will make your product a reality. Whether it's just one full framework or a combination of a framework, databases, things like that. Um, Storage, if you're in the cloud provider, there is a lot to choose from depending on where you want to go. This is usually very related to the architecture or the overall architecture of your product. So if you're just getting started with an idea and you don't really know where to go or what kind of technologies you want to use, one thing that I always try to do is just draw the architecture, just have some sort of high level overview of what I want to do. Try to think of what components are going to be interacting with each other, what based on the needs, based on the requirements for the product I'm going to be building. And then for each of these boxes, I try to start thinking about which technologies I'm going to be using. And this is, again, it can be any kind of technology. We're talking about like front-end frameworks, for example, or libraries like React, Angular, Vue, or we're talking about full stack frameworks like Next, or something for Laravel for PHP, something like Django for Python. It really depends on what you're trying to build. Even if you're like working on not a web project, maybe just a game that you're building, and you're trying to come up with the best framework or the best integrated development environment, are you going to be using Unity or are you going to be using Unreal? It really, the tech stack, it goes out even outside of what you're directly interacting with, not just the code or the language. It goes out to the type of storage. Do you need some sort of storage? Do you need a database? What kind of database are you going to be using? There are so many. Are you going to be interacting with external APIs? Which ones? Why? Are you going to be using storage, saving files? What kind of storage? Are you going with something cloud-based, a CDN, or are you just going to be saving things locally because there's no big requirement? There are a lot of questions to be answered when you're defining your tech stack. The more questions you answer, the bigger the tech stack might become, but the more detailed it's going to be. And in some situations, you might even find that there is overlap between the solutions that you're coming up with, and then you can simplify it. But the point is, this is what we're trying to define here. This is what we're trying to understand how to define. And of course, why do you want to do it first? Because it's the basis for everything that you're going to be building. You might say, well, I'll just start picking the language and maybe the framework, and then I'll wing it. And that's completely fine. The thing that you have to understand is that based on several factors that we're going to be covering in a minute, that just wing it decision might mean that you have to, in the future, rewrite parts of your product. You might be doing more work than needed just because you didn't spend a little bit of time thinking ahead of time. Some of the main factors to consider when you're building or when you're deciding on what your tech stack is going to be are the project size and complexity. You're not going to be using the same tech stack if you're building a corporate web page, or if you're building a game, or if you're building a complex platform in the web, or if you're building a CLI tool. I mean, there are so many types of applications, projects, that you really have to keep that in mind, the type of project that you're building and the complexity of that project. It's going to be filled with features, or it's just going to be a static website. And even then, how many pages is it going to have? Is it just like some simple and never changing static website that has 10 pages with information and that's it? Or is it just going to be a very active and very updated blog, for example, that it's going to grow from 10 to 100 to 1,000 articles very quickly. That's also, complexity. The scale of the information that you have to deal with will also inform your decision when it comes to tech stack. Another very important factor to consider is the team expertise. Essentially, whether you're building this with a team or just you alone, you have to consider the developers working on this, what kind of expertise they already have. Not because you just want to stay with what is known, but because you have to factor in the gap they have between what they already know and what they will have to know when picking up new technology, because that gap is going to translate into extra time in your initial estimates. So, and I'm one for always pushing developers and ourselves to learn new things and to come up with or to use new technology to make sure that we're stay relevant and up to date. If you stay with technology technology that you knew 10 years ago, then chances are you're just going to be outdated very fast. So yes, pick new technology if you have to, if you want to, but also keep in mind when you're deciding on that tech stack that the farther or the bigger the gap between what is known and what has to be learned will also affect the initial estimates. Once your team has ramped up and is already aware or proficient with the new tech stack, then that's fine. The gap is going to be gone. But at the beginning, estimates might require a little bit of a buffer to keep that training or that get to knowing that technology in mind. Another very important factor to consider is the need to grow and scale that your project or your application is going to have. Again, if you're just building a simple web page that is not gonna either be receiving a lot of traffic or even it will not grow much on its structure or the kind of information that it shows, then it relates to a complexity. Essentially, you don't really want to use a very complex tech stack for this. Now, if on the other hand, you know that your application is going to grow or is going to scale, maybe on the amount of users, maybe you're expecting a very high number of users, or perhaps you know that right now you have 10 features that you're working on for the MVP, but down the line, 6 months in the future, you're going to be working on 10, maybe 30 more features and so on. So the complexity is going to also grow of the code base of the application itself. So keep that in mind when picking or choosing your tech stack, because you will need something that allows you to organize your code in a way that you can make it grow, and the complexity of the code can keep growing, but at the same time, it's manageable. Same thing for something that scales on the resource base, essentially. If it needs more memory, if it's going to receive more traffic, thus requiring more processing power, then you have to make sure that whatever you're using is designed to scale as well. Maybe something that can be deployed on cloud, maybe something that can be deployed as a serverless function. Keep that in mind as well. Usually, this is not always the case, but usually these frameworks, these technologies might be open source. Or might be open source and have an enterprise alternative that if the company pays for it, then you have like extra support, people helping you, some sort of SLAs to help you to ensure that whatever you need, whatever help you need is given. But if that's not the case, if you're not paying for it, maybe you're just working on something that is a side project and you want to save as much as possible, then you want to look at the community around the piece of technology that you're looking at. If it's something that is actively being worked on and a lot of people are contributing to or creating content around, or maybe there are Slacks or Discord channels that filled with people answering questions, then those are signs of a very of a good choice. Essentially, those are signs that show you that if you need help, if you need assistance, or if you need to understand how to do something that you've never done with that technology, you'll find help somewhere in that community. So that's a good thing. That's a good factor. That's a good indicator when it comes to picking the right piece of technology for your tech stack. If on the other hand, obviously, you see a repo that hasn't been worked on for 3 years, there is nothing from the year in terms of content around that technology, and whatever public channels that were there are gone or just not really active, then maybe you don't want to go that way unless there is no alternative, which would be really, really weird. You don't want to touch that piece of technology, because the moment you have a problem, you're going to be alone when trying to solve that, and you don't want that to happen, essentially. And finally, obviously, costs considerations. Again, going back to the previous point, a lot of open source solutions or technologies do have an enterprise alternative that allows you to gain that extra confidence in terms of support. Many clients, many teams, or many companies will pick that so that they know that they can throw that responsibility somewhere else, essentially. If there is a problem with the tech stack, they know they're paying, essentially, a lot of money usually for someone else to solve those problems. That way, the dev team can focus on not troubleshooting, but rather working on new features and moving the product along. So that's one thing. Obviously, if the team is small, if there are not a lot of fans, or if you're just working on your own side projects, cost considerations are also important. So you have to really understand the scope of the project and the effect that those costs will have on the overall development workflow, essentially, and the speed of development. Also, this is not just about costs of support, but rather cost of ownership. Let's put it that way. So as a company, as a team, or as an individual owning this technology in your tech stack, how much is that going to cost you? And when I say cost you, I don't just talk about money, which is one of the factors, but also time. How much time do you need to get your team up to speed to use that technology? Are you going to require trainings? Are you going to require certifications to use that? That's also time and money spent in other things that are not directly related to the project. How much time and effort are you going to spend working with this technology when something happens, when there is a problem that needs to be troubleshooted? These are all considerations that translate into time spent away from the project, and that essentially is a cost to your project. So you want to avoid or reduce the cost of ownership as much as possible. Maybe you can do that. In some situations, you can do that through just paying for an enterprise version of whatever technology you're using, and then that you do have a cost, obviously, but it's reduced, if you will, to just money, which if you already have, if you don't have a problem as a company, or the client that you're working with doesn't really have a problem with that, then essentially there's budget for that, then you can definitely avoid the other type of cost, which is time and effort, which I would argue that is way more expensive than just money, because that's just time and effort spent somewhere else and not moving the product along, essentially. So those are all the factors that you have to consider when picking a tech stack, right? We're talking again, just to summarize, we're talking about project size and complexity. We're talking about the expertise your team already has, or you already have. The scalability and growth requirements from your project based on code complexity, as well as traffic and the amount of resources that needs to be consumed. All of that has to be factored into the decisions that you have to take. Obviously, in some situations, the community support is crucial. So also keep that in mind when you're picking up the technology. And finally, the cost considerations. Again, not just money, but rather cost of ownership, and consider reducing it as much as possible. Maybe even reducing it to just one type of cost, which is money, and then ensuring that your team can focus on what's really important. The final tech stack for your specific product is going to be your own tech stack. That means there is no cookie cutter solution that will solve everybody's problem. Obviously, there is way too much technology around. Let's put it that way. There are way too many options to choose from, and there is no one better. No matter the industry, you don't have a single winner. You have multiple ones that are alternative to each other, each one shining on their own specific focus. So you have to make sure that you have a very clear definition of what your product is going to do to understand the needs of it. That said, there are patterns, there are stacks, right, that are predefined and usually are good starting points to then modify or base the rest of your stack on it. What am I talking about? I'm talking about something like MERN, which for web development, it means MongoDB, Express, React, and Node.js. Those are like the basic ones. Obviously, MongoDB will be your database. If you don't need something that handles structured data or relational data, then Mongo is usually a good choice. Express, it's kind of an outdated choice, but still the framework is still being worked on. There is an active community around. React, clearly one of the most common on popular choices for front-end work. And finally, Node for everything else to tie together and really top-notch, especially if you're on web. And there are variations. You could use LAMP. Is a very old one. I used to work on LAMP back in the day. I don't know if it's still very used. It used to be Linux, Apache, the Apache web server, MySQL, and PHP. There are probably better and more modern alternatives, but that's just web dev, right? I mean, if you're doing, for example, a data science project, you usually have something like Python-based, so like using Python with NumPy, with Pandas, with the scikit-learn module, TensorFlow, and Keras on top. So that's also very common. That's also like a cookie cutter that works with many solutions. Obviously not for everyone. If you're, for example, a data architect and you're usually there like defining data platforms and data governance solutions and so on, then obviously some of the you can go with the architectures and tech stacks provided by the major cloud providers like GCP, AWS, or Azure, or you can go with open source solutions and say, well, I go with Kafka for real-time ingestion, and there are way too many options. But that's the whole point. So many options out there that there is no single pattern that works for everyone. There are given architectures, patterns that you can start with. Again, if you're working on cloud platforms, for example, all major cloud providers will give you some sort of de facto architectures for different use cases. If you have real-time data, if you have a mixture, if you only worry about data analytics, if you want to do AI, there are a lot of options out there, but you can just copy paste and hey, magically it'll work. You have to pick the one that resembles the most or has the most sort of solutions for your problem, and then just add on top of it or modify it to suit your needs. That's sort of like why or how you would do that. Are there better ways than just looking around? Definitely, there are not a lot of options so far that will give you all the details that you need. Usually that comes from experience, working with other people that know or have been around for a long time. So definitely you will be doing a lot of reading if you haven't really worked on or if this is the first time you're working on one of these type of projects. Essentially, if this is the first time that you're doing web dev or creating the architecture for an entire web platform, then probably you'll be doing a lot of reading or asking a lot of questions to people who have done it in the past. That said, to kind of solve that problem, I'm working on a little project called CodeClash.net. I will be linking that in the show notes. If you're interested in comparing technologies, I'm trying to provide that kind of information, essentially. How one framework compares to the other, how one language compares to the other, and even tech stacks. So trying to fill in that gap and give you at least a starting point, some sort of pros and cons, some sort of like default use cases for each one. So you might have an idea where to get started. Now, that said, when it comes to finally making the list, deciding on your final tech stack, so I would suggest doing two things. On one side, obviously, a lot of reading, a lot of research will be needed, right? But you'll find that, once you start expanding your product into an architecture and you separate that architecture into layers, right? Like front end, back end, and you separate other aspects of it, like processing, like data storage, and so on. So do that layer separation and then start looking at common or most popular technologies in those layers, in each of those layers. Once you have some options, start matching, start looking into like what your team already knows. How proficient are they with these options? How active are those options? Are they open source? Do they have a community? All those aspects need to be essentially applied to this. My suggestion here in this research phase is pick 3 options. No more. You don't really need more than 3. If you go 4, 5, 6, then you're just wasting a lot of time, and you're going to be finding a lot of overlap that is just going to confuse you more than provide value. Why? Because, and this is kind of a practical approach to look at it, out of all those options that your research will yield for one particular layer, there usually isn't a single best one for your context. Even if you map and you consider all your context, right? Your team expertise, the community, the requirements, the scalability, and so on, there's still going to be several options. And the one you pick is either going to be defined by your client. If you have a client, they might have a preference. And in that case, if all of them are equivalent, then just go and make them happy. Or if you don't have a client and you're your own client, then just pick one. Once you've done the research, once you've seen the overlap, once you've seen all the options, in the end, you have to pick one. Just obviously don't just toss a coin, but rather base your decision on one of these factors that you're taking into account. What weighs more when you're thinking about your product? Is it the community support? Is it your team's expertise because you want to go fast? Is it the scalability because you know the product will need to scale fast and high? Once you have the final 3 options, just pick the one that leans the most towards your most important factor in your context. That's kind of my 2 cents when it comes to that. But do create some sort of a matrix where you score all these options, all these 3 options against all the factors, so that you can see how that decision is taking place. That way you're not biased internally with when you're thinking about the solution. Maybe you have one in mind already. Just make sure you create that matrix. Make sure you even color code it if you can, and then look at it. And once you start seeing that, maybe the decision isn't that obvious because they're all great on different areas, then just pick 1 or 2 of the factors that are most important for your product, and then out of all the 3, the one that leans more toward those factors is going to be the winner. That is one way to look at it, and that is one way to make the decision, especially if you don't have a lot of time, right? Usually research has to happen. Now, if you have a little bit more time, if you do have that extra 2 to 3 weeks of more time before the actual project starts and before you have to make the final decision on the tech stack, then a good option would be to develop a couple of POCs with the different options. So your team can look at the kind of most common issues that they will run into when creating the final project, see how quickly they can solve them, and how to see essentially how comfortable they are with those technology stacks. Make 2 to 3 POCs, no more than that. You don't want to spend a month or 2.5 months working on different POCs to make that call. Ideally, you do have some experts in your team that have done this or something very similar in the past to help you decide, at least for some of the choices in the different layers. But if there are options that are equivalent essentially, and you can't really make up your choice for the same layer, then create a few POCs that will help you and your team see which technologies feel best. There is definitely a difference between doing a theoretical research and looking at what people think about it, and then doing a practical test and seeing how your team feels with that technology. So if you do have the time, make sure that you also create a few POCs. It'll be good. And that's it, essentially. Picking the right tech stack for your product, for your project, is critical. Obviously, it's going to help you make the product, or it will help you destroy it. It will help you get in time and release on time when you need to, or it will delay everything that you're trying to achieve. Now, is it the only factor? Obviously not. There are a lot of other factors that can affect a product, the development of a product, but definitely it's a very critical one. So spending some time and doing some research on picking the right tech stack for your specific context is absolutely mandatory, I would say, for any project. When it comes to trying to decide how you make that decision, how you make that call, some factors to take into account, again, are the size and complexity of the project, what your team already knows, or what you already know how to do and have done or used in the past, the scalability and growth requirements for the product and for the code of the product as well, the community support around those choices if it's important to you, and finally the cost considerations, again, not just money but also cost of ownership as in general. Now remember, once you take those factors into account, you will have several options for different aspects of your project that are just overlapping, that are equivalent. So make sure you create that matrix, you see the solutions, and then if you still have a problem making that choice, either pick one factor that is crucial to you and then pick the one that is closest or has a focus on that factor, or have your team create a couple of POCs using those options and see which one they like the most. In the end, the final tech stack should be unique to you and your context. Chances of you reusing someone else's tech stack efficiently and getting the most out of it are slim. You can definitely use someone else's, just copy paste and adapt to it, but then you will be spending a lot of time just you and your team adapting to the workflow that someone else has given you, instead of you adapting the tech to your workflow, which is how it should be, in my opinion. Now, remember, there is a third option when it comes to trying to make that decision. Check out codeclash.net. The URL, I link it in the show notes. It's code-clash.net. There I'm uploading slowly different tech comparisons. Hopefully I'll have more in the future, but if it's useful to you, just let me know. I'd love to keep working on that, on the project, if it is. And that's it. That's the end of the episode. I hope that it was useful to you, that it gave you some sort of idea on how to define this and the importance of defining the right tech stack. And if you liked it, consider subscribing to the podcast or the YouTube channel if you're watching on YouTube. And I'll see you around on the next one. Until then, bye. And that was it for this episode of the Scripting Them podcast. Thank you so much for listening. Remember that you can find me online on Twitter at DeleteMan123. And you can also find the podcast YouTube channel just searching for the Scripting Them on YouTube. Thank you again, and I'll catch you on the next one.